All right, in this video I'm going to talk about three more properties of the Laplace transform that are going to be really useful for us. So the first of those is, say you've got the Laplace transform of some function, and let's say that's a function that you know the Laplace transform for. And we're going to call that that solution f of s. What we're saying with this first property, the translation in s, is that if you multiply this function by an exponential function, e to the at, then all that's going to happen with this solution is that this is going to be now s minus a. So if you know the Laplace transform for some function, you can easily figure out the Laplace transform of that function times this exponential function. So let's do an example. Let's say we want to find the Laplace transform of e to the at times the sine of bt. Well, we know the Laplace transform of the sine of bt. We know that's equal to b over s squared plus b squared. So since this that we're trying to find this Laplace transform for is just this function times e to the at, all we have to do is replace this s with s minus a. So this is going to be equal to b over s minus a squared plus b squared. So that's that's our answer right there. All right. The second property that we want to talk about is the derivative of the Laplace, or actually the Laplace transform of the derivative. So the Laplace transform of the derivative of some function is going to be equal to s times the Laplace transform of that function minus that function evaluated at 0. So, so let's do an example with this. If we've got, and this was one of your homework problems last week, the Laplace transform of the cosine of bt. We can solve this using the fact that we know the Laplace transform for the sine of bt. That we know is b over s squared plus b squared. And so the derivative, if this is our function, so we're going to set our function f of t is equal to sine of bt, then the derivative of that function is b times the cosine of bt. And the Laplace transform of that derivative is going to be the Laplace transform of the function, so b over s squared plus b squared times s, so we'll put an s up here, minus the function evaluated at 0. So if we take f of 0, if this is f of t, f of 0, well, sine of 0 is 0. So this is just going to be minus 0. And now notice that the only difference between here and here is this b. That b is just a constant which we can bring out front. And then we can divide the whole thing by b on both sides. Those b's will divide to 1, and so will those b's. And so we're left with the Laplace transform of cosine of bt is equal to s over s squared plus b squared. And hopefully that is the solution that you got on your homework last night, or last week, though I imagine that it probably took you a few more steps than that. So this is handy here. All right, the last one. Oh, before I leave this, let me put this back up here. Is equal to s times the Laplace transform of f s minus f of 0. I want to do really quickly, if we know that this is true, then what would be the Laplace transform of the second derivative? Well, the second derivative is just the derivative of the derivative. If this is the derivative, then let's take the derivative of the derivative function. So let's f prime minus f prime of 0. So now this, notice, not there, right there, this piece is this. So so we can replace this with all of this. So this is going to be equal to s times all of this, s times the Laplace transform of the function times s minus f of 0 minus f prime of 0. And so distributing that s, we get that this is equal to s prime, or s squared times the Laplace transform of f, s minus s times the function at 0 minus f prime of 0. That's the Laplace transform of the second derivative. And you can imagine that you can continue doing that. And the general formula for the Laplace, the nth derivative, is in your materials. All right, so moving on to our third example, we've got, that was the Laplace transform of a derivative. Now the derivatives of a Laplace transform. So let's say we've got a Laplace transform of a function that we know. And now we're gonna multiply that function by t to the nth power. Well, that's going to be equal to -1 to the nth power times the derivative of the Laplace transform of this function f of t. So the nth derivative, so the d to the n of f over ds to the n of s. So there's our formula here. Let me show you an example of how this is going to work. So let's take the Laplace transform of t times the sine of dt. And we know, of course, that the Laplace transform of the sine of bt is b over s squared plus b squared. All right, so the Laplace transform of t times this is going to be equal to -1 to the first power, because this is t to the first, times the first derivative of this Laplace transform. So the derivative of this is going to be, so let's just call this f prime of s, is going to be equal to, if this is f of s, then f prime of s is going to be the derivative of this. Let me see, let me rewrite this as b times s squared plus b squared to the -1 power. So the derivative of this is going to be, b, remember, is just a constant. So it's going to be b times negative b, because we'll bring down that exponent, times s squared plus b squared to the -2 times the derivative of this, which is 2s. So that is -2bs divided by s squared plus b squared quantity squared. All right, so that's the derivative. And the Laplace transform is going to be t times sine of bt is going to be equal to -1 times that derivative. So this is just going to be positive 2bs over s squared plus b squared squared. So that's going to be our answer for that one. And so hopefully that's enough to get you started with these three new properties.